Alright, so today we talked about vectors. Alright, so first part is we're going to give some definitions. So a vector is a directed line segment with both magnitude and direction. Alright, so there's vector. Okay, then we're going to be talking about the initial point, which in this case we're going to denote as being P. And so that's your starting point of your vector. And the terminal point we're going to denote as being Q. So that's your end point of your vector. So if I were to have a point here, that'd be my initial point. I start at P, I go, and I end at Q. So initial, terminal. Alright, the magnitude is the length of your vector. So the length found by using the distance formula. Okay, and that distance formula we've used before. It is, again, this vector is written as PQ with kind of a half arrow drawn above it. So magnitude is that same thing, but now it's surrounded by two lines. These two lines right here denote that we're finding the magnitude, finding the distance between those. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared, all being the square root of that. Alright, then the direction, so this tells us how does our vector open. Does it open going to the right? Does it go to the left? Does it go down? What does it do? So the direction you find by using the slope formula. So that is y2 minus y1 over x2 minus x1. Okay, now the notation that we're going to be using is, or that's in your book as well, is bold lowercase letters. And usually they're U, V, and W. So they're just bold. Alright, so now let's look at an example. I'm going to let vector U be from initial point P00 to terminal point Q32, and I'm going to let vector V be from initial point R12 to terminal point S44. And I want to know that, or I want to show that these vectors are indeed the same. Okay, to do that we need to show that same magnitude and direction. Okay, so we need to show that they have the same magnitude and the same direction. Okay, so to do so, we need to find the magnitude first. So that's using the distance formula. Let's find the magnitude of U first. So I'm going to take my x's, subtract them, square them. So I'm going to have 3 minus 0 squared added to 2 minus 0 squared, which equals the square root. 3 minus 0 is 3, squared is 9. 2 minus 0 is 2, squared is 4. So I have square root of 9 plus 4, which is root 13. Okay, we'll do the same thing with V. Okay, so x minus x squared plus y minus y squared. Again, 4 minus 1 is 3. 3 squared is 9. 4 minus 2 is 2. 2 squared is 4. 4 plus 9 is 13. So again, I get root 13. So if we look here, our magnitudes are the same. So now we need to show that they have the same direction. So their slopes are the same. So I'm going to look at the slope of U. Subtract my y's. So 2 minus 0 over 3 minus 0 equals 2 over 3. Okay, now I need to look at my slope of vector v. And I have 4 minus 2 over 4 minus 1. 4 minus 2 is 2, 4 minus 1 is 3. If we look, those are the same as well. So therefore, vector u is equal to vector v. They just start and end at different places. So basically, we just took a vector and we shifted it some. Alright, now let's look at component form. Okay, the standard position is a vector's whose initial point is 0, 0. So the vector starts at the origin. Okay, so a component form is when that happens, when it is standard position. So that's the next point, component form. It's written as vector v, v1, v2. So these are different kinds of brackets. They're kind of like inequality signs, less than, greater than signs. If it is written in this form, then it is assumed to always be true that its initial point is 0, 0. Okay, so always initial point is 0, 0. A few other vectors we need to talk about of the 0 vector. I have 0. So if we have initial point at 0, 0 and an end point at 0, 0, that means there's no magnitude or no direction. A unit vector, we're going to call it u. When your magnitude's 1, that's a unit vector, so that's kind of like back to the unit circle. Okay, and then to get your component vector, if you don't already have it, you take your terminal minus your initial, terminal minus initial. Okay, that'll give you, basically we're taking a vector that's up here, shifting it so it'll be at the origin now instead. So example 2. I want to find the component vector and the magnitude, the component form of the vector v that has initial point 4, -7 and terminal point -1, 5. Okay, so I need to find the component form. It doesn't start at the origin, so I want to make it. I basically want to take these points and I want to shift them so now where it'll start at the origin. So I'm going to take my terminal minus my initial, so -1 minus 4, comma, terminal minus initial, 5 minus -7. So this becomes -5, 12. So this is my component vector. So basically I had a vector that if I were to plot these points, -1, 5, and 4, -7, we'll just say it's down here. I shifted this whole thing to where now it's going to have an initial point at 0, 0 and then a terminal point at -5, 12. So they're still the same length, still the same direction, but now it's just shifted to where it starts in the origin instead. Okay, so there's that. Now I need to find the magnitude. So the magnitude of v now, because it starts at the origin now, I'm just going to take these numbers and square them and add them together, because it would be using -5 plus 0, or 12 plus 0. We don't have to worry about the zeros because it keeps the numbers the same. So this becomes square root of 25 plus 144, which is the square root of 169, and the square root of 169 is 13. So your magnitude is 13. So here are your two answers, your component form and your magnitude. Alright, your assignment is A14, page 456, numbers 1 through 10. Please let me know if you have any questions, and good luck.